Welcome to the spoken tutorial on simple machines. In this tutorial, we will demonstrate pulley system and lever principle apps. Here I am using Ubuntu Linux OS version 16.04, Firefox web browser version 62.0.3. To follow this tutorial, learner should be familiar with topics in basic physics. Using these apps, we will show how a pulley system works. Calculate the necessary force to pull the load. Show the working of a lever. Explain how to achieve a balance condition. First, we will define a pulley. A pulley is a simple machine that is used to lift heavy objects. We can either use a single pulley or a combination of pulleys. For example, pulleys can be used in wells, escalators, rock climbing, flagpoles, and others. Use the given link to download the apps. I have already downloaded Apps on Physics to my Downloads folder. After downloading, HTML5N folder appears in the Downloads folder. Double-click on HTML5N folder. We see two folders, namely PH and FEN. Now double-click on the FEN folder. In this folder, we see the apps in JavaScript and HTML format. We will use the apps with HTML file format. To open the pulley system app, press Ctrl F keys simultaneously. In the search bar, type pulley system. Right-click on pulley system _en.html file. Select the option Open with Firefox web browser. Pulley system app opens in the browser. The app interface opens with two panels, a yellow panel with a pulley system and a green panel to change and display parameters. In the yellow panel, notice that a load is attached to the pulley with the help of a rope. We can either raise or lower the load using a spring scale. Click and drag the mouse to raise or lower the load. Observe that there is no change in the value on the green panel. This is because the necessary force required to drag the load remains the same. On the top of the green panel, you can see a drop-down list of pulleys. List has 2, 4, and 6 pulley systems. The weight of the load is displayed in the white box. The default weight of the load is 14 Newton. We can change the value of the weight from 1 Newton to 40 Newton. We can change the weight of the loose pulley in this box. This is the total weight of the 4 pulleys. The necessary force to lift the load is calculated using the app. At the bottom of the green panel, we have spring scale and force vectors radio buttons. By default, spring scale is selected. Let us demonstrate the working of the pulley. Observe that weight of 20 Newton is hanging from the 4 pulley sections of the rope. Each section of the rope has 1/4 of the total weight. In the app, force required to raise the weight in air is calculated. The necessary force is calculated using the formula F equals to WL plus WP upon 4. WL is weight of the load and WP is weight of the loose pulley. Now change the weight of the loose pulley to 20 Newton. Observe that the necessary force is changed to 10 Newton. Next, change the weight of the load to 30 Newton. Observe that the weight of the loose pulley has changed to 10 Newton. This is because the spring scale limit is 10 Newton. Values more than 10 Newton are automatically changed. As an assignment, Change the weight of the load to 25 Newton and weight of the loose pulley to 10 Newton. Calculate the necessary force and verify your answer from the app. Next, we will move on to Lever Principle app. To open Lever Principle app, right-click on lever_en.html file and open with Firefox web browser. This app shows a symmetrical lever with some mass pieces. Each mass piece weighs 1 Newton. At the bottom of the interface, lever principle is defined. A lever is in balance if the total left side torque is equal to the total right side torque. Observe that the lever arm is shown by green and orange rectangles. Length of each rectangle is 0.1 meter. At the bottom left of the screen, torque is calculated. Torque is the twisting force that tends to cause a rotation. The point where the object rotates is the axis of rotation. In the app, fulcrum is the axis of rotation. We can calculate the torque using the formula tau equals to F into R perpendicular. Green and orange rectangles indicate perpendicular distances. We can change the hanging weight by clicking and holding the mouse. Observe that the lever is unbalanced. This is because torque on both the sides is not same. Notice that the value of left side torque is reduced to 0.9 Newton meter. What happens when the hanging weights are removed from both the sides? Let us hang weights at different distances to the left of the fulcrum. Click and hold the mouse to add one weight on the third rectangle. Add two weights on the fourth rectangle and one weight on the fifth rectangle. Observe that the lever is now unbalanced. Let us add weights to the right side of the fulcrum to balance the lever. Click and hold the mouse to add one weight to the first rectangle. Continue to add weights to third, fourth and fifth rectangles. Notice that the lever is now balanced. As an assignment, solve this numerical. Let us summarize. Using these apps, we have observed how a pulley system works, calculated the necessary force to pull the load, observed the working of a lever, explained how to achieve a balance condition. These apps were created by Walter Fend and his team. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials and gives certificates on passing online tests. For more details, please write to us. Do you have questions in this spoken tutorial? Please visit this site. Choose the minute and second where you have the question. Explain your question briefly. Someone from our team will answer them. The Spoken Tutorial forum is for specific questions on this tutorial. Please do not post unrelated and general questions on them. This will help reduce the clutter. With less clutter, we can use these discussions as instructional material. Spoken Tutorial project is funded by MHRD Government of India. This is Himanshi Karwanje from IIT Bombay. Thank you for joining.